Okay, so we're looking at page 470, we're looking at the fundraising piece. So read that fundraising piece out to me, Hayden, please.
Okay, or what to use the function?
The fundraising.
Oh, that's
Yes.
a lot. Wait.
Just read the first paragraph. Everyone should be looking there, page 470.
In 1996, the first time
Tibetan.
Freedom concert regarding by many as the single greatest culture event in modern rock history took place in the Golden Gate Park in San Francisco. This was the first in a series benefit concert organized by Milarepa Fund to raise awareness about nonviolence and the Tibetan struggle for freedom, as well as encourage youth
Activism.
activism.
Okay, Calliope, can you read the next one?
Sorry. The primary goal for the Tibetan Freedom Concert was to raise awareness, not money. However, careful planning was needed to ensure that the event would reach a large audience and that it would not lose money. The profit from any event will be the difference between income and operating expenses.
Okay, so what they're saying here is that the profit always equals what the income is minus your expenses. We've talked about that. The kids that are doing the Shine project, my son and I were having a conversation. He wants to do Shine crafts. And I was like, okay. And he said, I'm going to use these beads. I'm like, well, I bought this. You got to pay me 20 cents a bead. And he's like, well, I'm not going to do that then. Instead, I'm going to use this yarn that Santa Claus got me. And now I only know Santa Claus isn't going to take anything from me. So now I don't have to pay anybody anything. And I'm like, what? So now he's not using stuff that he has to pay me because he wants more of a profit.
I mean, to be fair, 50% of the profit already does go to the
And
school.
he knows that. He's like, why is that fair? I'm like, oh, you're trying to save money. But so the organizers plan the event. How many variables do they need to consider? What do they need to consider as far as that goes? What are some things they need to think about in order to make sure they make enough money? What are some things they need to think about? Teresa.
I guess if it's a concert, like who's performing, because like if it's like super big people, then they're gonna have to pay them more. So like they have local people who do it for free, then it's like easier.
Excellent. So who's gonna come? Will it draw enough people in? What else do they need to think about? Say I have it at the Civic Center as opposed to having it at Orange Peel. What would be the difference between those two places if you've been to either of them? Yeah, Teresa.
One's probably gonna be cheaper.
One might be cheaper. What else might be? That's true. What else might be true? Yeah, I could probably fit more people at one than the other, right? If I were to say, hey, we're going to have a big dance at Rainbow, and we're going to have it in the Butterfly House. How many people can we invite to the Butterfly House? Comfortably. How many people can I invite to the auditorium? 100, 200, maybe 50, 60, 70 is usually what we're at, but we probably have 100. We probably have 100 people in there. William, are you on task or are you going off on a tangent?
I was going to say you can probably put even more on the
Playground if we want to even invite more. Exactly. So they want to think about that and then think about operating costs. I like that Teresa thought about that. One place might cost more. So which place is more effective? So you're thinking about all those things. Let's look at number 3. So suppose that the group of students decided to organize a local concert to raise awareness for the funds for the Tibetan struggle. And the planning for the concert led to this information. The relationship between the number of tickets sold and the ticket price in dollars can be approximated by a linear function called this. So this is how much the tickets, we have 4, is it 4,000? Minus what?
250.
Let's break this down and look at that a little bit. So they're saying the relationship between the number of tickets sold, so this is the number of tickets sold, is going to be 4,000 minus 250x. And the expenses for promoting and operating the concert will include $1,000 for advertising, $3,000 for pavilion rental, $1,500 for security, and $2,000 for catering the T-shirts. So how much is all of that add up to?
Wait.
Yes.
So what is the thing at the top?
This is just telling you profit.
The one in the middle, I guess.
This one?
Yeah.
So this is saying tickets, this is what they've given us so far. We haven't broken it down yet. So it's just in the equation. They said that the linear function, the number of tickets sold, can be represented by this linear equation. And the ticket price X. So this right here, they're saying that the ticket price they gave us the equation. They're going to give it out to you right away. They're saying here's an equation that represents the number of tickets sold and the ticket price. They're saying that the number of tickets sold is a direct relationship to the ticket price. So if I said, for example, Elton John, you guys know who Elton John is?
Yeah.
So Elton John is an older singer, but he's a really famous singer. And so he is on tour right now doing his final farewell tour. And I was like, oh, that'd be really cool to go see him, because this was my only chance to see him. I looked up tickets, and the tickets up in the nosebleed seats are like $250. And I'm like, I can't justify spending $1,000 to bring my family forward to go see this concert. But I might see someone else on tour, and the ticket's only $50, and I might say, okay, I can afford that. There is a limit that people are, just like Sharissa said, it depends on who it is. There's a window of how much people are willing to spend depending on who it is. Elton John, obviously, people are willing to spend $200 to go see him in the nosebleed seats because there's not very many seats left. It just gets rid of me, who can't afford to spend that much money on a concert. Bruno Mars, my son would really like to go see Bruno Mars play in concert. His tickets are ridiculously priced. I'm like, there's no way I can afford that. But the reason why they're that price is because there are a lot of people who can afford it and will do it. So like, where's that pricing? Now, if Bruno Mars tickets on the nosebleed seats were $1,200, I bet you nobody would go to the concert. There's a window of pricing that's going to work, right? If I told you guys you could go bungee jumping, if you ever wanted to go bungee jumping. So let's say you all really wanted to go bungee jumping, and I said, and it's $1 to go bungee jumping. I might not even want to do that because I might be like, why is it only $1? That sounds questionable. But it might be $500, and I'm going to be like, yeah, I don't need to spend that much money for that either. So what's that window of pricing that works the most? And this is saying, this is how it's represented, that the ticket, this is the number of tickets sold. Let's put that down so we have it. So for me, I'm very visual, so I like to draw this. So if I were to draw this, this is saying at 4,000, and this is Y, and Y is the number of tickets sold. So that means how many tickets could be sold potentially? 4,000. So that means there might be 4,000 seats at this venue.
Do we have school Monday?
I'm going to keep teaching. You can ask me that during study hall.
Okay.
Thanks. Okay, so then we have minus 250x, okay? So that means I'm going to go over 1, down 250, over 1, down 250, over 1, down 250 until I get all the way over here, right? And so if I were to figure that out, when is this 0? When is this 0? It would be when 250 goes into 4,000 or 16 times. It'd be at like 16. So here's my line showing that once I get to $16 per ticket, I'm not going to sell any tickets. I won't sell anymore. So that's just, and so does it always make sense? It doesn't. It's just a window of thinking about things. The expenses, on the other hand, how much do the expenses cost? It's just adding all those numbers up. How much does that total up to?
Wait,
Yes.
the first one is how much money you're making.
This is just number of tickets sold. We haven't gotten to profit yet. Okay, so this is just telling us number of tickets sold.
Okay.
Okay, now, so that's saying if depending on the price, this is how many tickets I'll sell. Okay, so now let's go on E. What's the expenses? The expenses were 1,000, 3,000, 1,500, and 2,000 for all the things, which ends up being $7,500. It's going to cost them $7,500 to have this ticket, period. How much money do they have to make to break even then? $7,500. So that's their goal, is they need to make $7,500. So the first question is, find a function that can be used to predict the income I for any ticket price X. So this is number of tickets sold, right? So we're going to use this, and this is where things get a little confusing because they keep using X. But this is the number of tickets sold, and this is the ticket price, right? Is that ticket price? That's what they say, ticket price X. So find a function that can be used to predict the income. The income would end up being, we need to know, and they're saying that X is representing the ticket price X. Find a function that can be used to predict income for any ticket price X. So I would put, if the tickets were this much, right? This is the price of the tickets. This is X, price of tickets. And this is number of tickets sold formula. So the price of tickets times the number of tickets sold. I'm going to write that in words so it makes more sense. So it's going to be income equals ticket price times the number of tickets sold. And then what I did is plugged it in. Now I'm going to use some color coding to help you see that better. Income is just what we're looking for, okay? This is your ticket price, right? Ticket price is X. And this is, stand off. This equation right here stands for numbers of tickets sold, right? So I plug that into here, number of tickets sold. So I'm saying the ticket price times the number of tickets sold is going to tell me how much money I make. So let's think about that. If I charge $1 for cupcakes and my number of cupcakes sold is dependent on another equation, how many cupcakes I can sell, a linear equation that they give me, then I would want to multiply my price of my cupcake times how many cupcakes I sell, right? Now, the question you guys get confused with, well, how do we know this? You'll know this because they will give you this. You will not have to figure this out ever. They're always going to tell you, here's the equation for number of tickets sold. Here's the equation for number of bungee jumps available. Here's the equation for. And in order to find, here's the equation for number of cupcakes sold. Okay? And since they give you that, then you know the equation for number of cupcakes sold times how much I sell my cupcakes for is going to give me how much money I make. So let me use Nick as an example. I told him he was going to make necklaces, that I was going to charge him $10 a bead. Let's say his equation ended up being that he could sell 100 necklaces. Okay, let's just say that's what it was, his equation for, and this is for number of necklaces sold. Okay, and this is the price he charges per necklace. And I said, well, what's his income? His income would be the number of necklaces sold times the price of necklaces sold times the number of necklaces sold. Kind of makes sense? It's a little confusing, it's a lot of words. So we have the income equation. Okay, so this is your income. Now, this equation right here is our income equation. Now, is that my profit? How do I figure out what my profit is? Yes?
Is it by solving for X or solving for P really? Or knowing the value of X?
Well, this is profit is income minus expenses.
Find the expenses.
What were the expenses?
$750.
Okay, so 7,500, 750 we lost. Okay, so now our equation is going to go, so for profit of this concert, my equation is going to be this equation, my income, X 4,000 minus 250X minus 7,500. So it's income, this was my income, and this is minus my expenses. I'm going to erase the board in a second to keep moving on, but I want you guys to just see that. Yes?
Will they give you the expenses?
Yes, they will give you the expenses. You might have to add them up, but they'll give you a list like they just did. Expenses, they'll also give you. They won't tell you, and you have to guess what the expenses are or come up with some random equation for the expenses. Nika, when you're ready for answers, I have your answers right here. And I did all those problems last week on my own. So if you ask me questions, I should be good, but it might take me a minute to read because that 3-day weekend threw me all off. I was like, I don't even know what I'm teaching today. Yes?
Why do you have to put X
In the front? Because in order to find income, I need to put number of tickets sold. Price of ticket times number of tickets sold. This stands for price of ticket X was standing for price of ticket, and this equation stood for number of tickets sold. And they were saying the number of tickets sold depends on the price. Because no one's going to pay $1 billion to go see Britney Spears do a concert. She's old school, right? I wouldn't spend $1 billion to go see. I probably never would have spent $1 billion. I probably never would have ever gone to Britney Spears concert. That's just me. Joni Mitchell, I might have spent $1 billion to go see. But, huh? Would you spend $1 billion to go see Joni Mitchell? I mean, Britney Spears? Did she even sing stuff? I don't even know. Yeah.
Wait, but how, if X goes up, then how is it? Oh, because it's more that you're subtracting from the 4,000.
Mm-hmm. So there's going to be a window. There's going to be a window of actual versus theoretical. That obviously you can't sell negative tickets, right? And you can't sell over 4,000 tickets either. So there's going to be a window of numbers that work to answer the equation and a window of numbers that don't relate to what you're saying. Can I erase what's up here or not yet?
So,
Can I bring my phone in here? Oh no, where's my picture taker? Oh, I bet you I do have it. Yes.
Your final answer is
That's my answer for now. We're going to work with that a little bit more, but I just want to give people a minute to get notes. This is very, very, very similar to what your homework will look like. I will do the same thing today. I'm recording the lesson because Aiden's not here, and I will send it home. I might start doing that every day. Although I don't.
Wait,
I have you looking at the floor. Yes.
does this connect to what we learned yesterday?
It will. I'm going to get there, how it's going to connect. It doesn't for you right now, but it will in a minute. Because I'm going to answer Maya's question today. Maya's question yesterday said, why does that negative b put over 2a work? Where does that come from? I'm going to answer it for you in just a minute.
So that means to divide, right? That line.
Yes, it does mean to divide. Okay. Yeah, I told Marley that yesterday, but forgot to tell you. Okay, so am I ready to, yeah, why it works always helps me understand it better. If I can see that big up, and I had to look it up, and then I was like, oh yeah, I knew that, but I just didn't know how to explain it. But it was funny when I looked it up to see so I could explain it to you. The first person was like, I asked my teacher in class why a negative b over 2a works, and the teacher's response was, don't tell me how to do my job. I was like, oh my gosh. I'm like, I can imagine if I said that. Like, I hope that you guys know I'm always willing to look into whatever you ask me. You want me to say that instead?
Yeah.
Don't tell me how to do my job. I didn't say that. Hi. That wasn't me. Hi. I love you.
Yeah.
You're great. Okay. Can I erase this?
We should have done this the day before we left for this trip, or the last day that we can
I could show you guys what a trip looks like.
give you the to read or not to read, which
Can
is
Can I erase this?
Friday.
Can I erase this?
Israel.
But it's not that kind of pie.
Yeah, but
Yeah, kind of.
the equation says pi.
Okay, so let's move on to look at, so let's look at those two equations again. So we have two equations, right? I have tickets, this is the number of tickets sold equals 4,000 minus 250x. And then we had what it would actually be for profit. And profit was, oh no, I'm sorry, income. Income was x times, profit is x times 4,000 minus 250x minus 7,500, okay? So we have these two equations. We have the one that just stands for income and the other one that stands for profit. I don't like to have parentheses when I'm working with problems that have to do with graphs or tables or anything like that. So I'm going to get rid of the parentheses. So in order to get rid of the parentheses, I have to give a little bit, distribute, right?
It's gonna become exponential.
Why is it going to become not exponential? What's it going to become?
Quadratic.
Yeah, why is it going to become quadratic?
It's gonna be like 4,000x and negative 250x squared.
Excellent. These are going to become quadratic. So let's go ahead and do that. We're going to distribute. Will, the other night we had homework with this and you were like, I'm not sure how to do this. If there's something outside of the parenthesis, you need to give it to everybody. Here's my basic Susan explanation of that. My hair's curly in this picture. I look scary. Whoa. Okay, there's me. Usually my hair's in a bun, so it's whatever. Okay, so there's me. I'm thinking about something, and I'm thinking this. Why on earth does this distribution rule work, right? Will's been doing math in his head since he was, I don't know, before he could walk probably. He's like, why do I have to write stuff out? I've been able to do it since before I could talk. I was doing algebra. Why are you making me write steps down? So this is what he was doing in his head. If it was 4 times 2 plus 3, In Will's head, he went 5 times 4, right?
Yeah.
And you did 4 times 5. He didn't write this down, and then he got 20. Well, when you move into algebra, you can't do it that way because we can't combine an x and a 5. So now we actually have to distribute it. So let's see what happens if I did that back when I did old math. What's 4 times 2? What's 4 times 12?
12.
I mean, 4 times 3. I do that all the time. What's 8 plus 12?
20.
20. So the distribution rule works. It's just a way of working with operations, okay? Because that's just my thinking in my head. I go back to what kind of math my son in 4th grade is learning all the time when I'm teaching him. And then I look at the things I'm doing with you. I'm like, oh yeah, that's how those connect. Math is real linear. It does connect all the way through. So there's always something you look at what we're learning now and how it connects to what you learned way back when. And it's always interesting if you can make those connections. So I'm going to distribute this, which means just like Quinn said, we're going to end up with this. And on this one, we're going to end up with and you know what I'm going to do with these equations? Because of my dyslexia and the way I think of things, I'm going to move things around. I like to move it so that my higher power is in the front and it goes to the lower powers. I'm going to switch this around to negative 250. I'm going to go.
Wait, so why do you have to do all this work?
I'm showing you something. I like getting things into standard format. I want to show you something.
Why are we distributing stuff?
I'm distributing it so I can get it into an equation that's easier for me to work with. I want to get it in its simplest form. I want to move this around too. Now remember, the negative stays with this guy. So I have negative 250 x squared plus 4,000 x. And on this one I have negative 250 x squared plus 4,000 x minus 750. I mean, gosh, now I say it. Thanks, Will. Yeah?
Is this problem C?
This is problem C, but this is working on C in some ways. I'm kind of working in the book and out of the book, what I think is important. So don't let the book, I'll bring up the book when it's important, but I'm showing you something. It is C, but I'm taking it to a different angle. Will, question? Why what?
That one is like the full.
They are like it. What's different?
One of them has expenses.
Yeah, one of them has expenses or C or a y-intercept value that's not 0, right? So let's remember what happens with those different values. When we looked at, I wish I could project this super fast. When we looked at that video that I showed you when I was manipulating the quadratic formula, do you guys remember that? It was when I was teaching you virtually from home. And I pulled up this quadratic formula and I moved the A, and when I moved the A, what happens to the equation? It went like this, 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 remember? It changed that direction. When I moved C, when I did C, oh, well, I'm knocking everything over. Oh my gosh, boy. I threw the pen at my face. This is all crooked.
Jason.
Okay, so
Jason.
so when I change C, what C does is it moves it up or down on that, wherever it is. It just moves it up or down, right? But the B one was the one that moved it kind of all over. Yeah, it moved it this way and that way. So let's talk about why. Let's look at this right here. Let's graph this one. And you don't need to graph it. We're not going to graph it perfectly. So what I do know, though, is where's the y-intercept on this? What's C on this equation? You don't see it at all, so therefore it's 0. So nothing's there. So this is where that crosses there. Okay, so then I would graph the rest of the equation. I'm not going to go crazy here and try and do it with the math, because these numbers are large, and this is when I look at it and go, I probably want to do this with the calculator. I could do it math-wise. I could find my y. Let me just do it for you guys. My A is negative 250. My B is 4,000, right? So my line of symmetry is going to be 4,000 over negative 4,000 over 2 times negative 250, which means it's going to be 4,000 divided by 500, which would be 8. It's going to be 8 over 1. Want me to show you guys that math? Does that make it easier? Negative 4,000 over negative 500. He's like, no, I got this. 8. Okay. So now I got 8, so that means the line's reflected over this. which means this is 8. How far is this going to be to the next point? There's 2 points. Is this equation going up or down? It's facing down. This is an n because there's a negative. I think of the upside down one as an n. An n is negative. So now it's negative 250. Now I got to find that point. I got to plug this into that equation to find the point that goes on that line. That's why I would use a calculator for this. But just so you can see what I would do negative 250 times 8 squared plus 4,000 times 8, which really isn't awful math. This is the one that's hard. I better figure this one. 16, so this would be 1,600 plus 32. Right? I think. This we're going to check math. So let's just make sure I did this right. I don't like trying to do the big numbers on the board real quick because I go fast. What? Is it?
Yeah, it's positive 1,600.
So 1,600. I did this wrong. Oh no, the whole answer ends up being. I did something wrong.
It's 1,600.
Oh, there you go. Times 32. There you go. And it ends up being 1,600. 16,000. 16,000 is what it ends up being. That doesn't make. Yeah, it does make sense. So I just used my calculator to do the math. I just plugged in the 8 to solve the problem, which means this is the other point. So I go over 8 and I go down. I go up. Sorry. 8, 16,000. That's the point. So that's that point. So this equation looks like that. So what's the max amount of money I can make? $16,000. That's what I just figured out. Okay, so that's what I figured out. Now that's this equation. That's the max amount of tickets I can sell. That's this equation. I haven't done the 750. What's going to happen when I add that negative 750 in? Where's the equation going to go?
Down.
When I do this one, it's just going to move it down. What else is going to be true about the equation? It's going to move down, but what else will stay? What else will be true?
Oh, but in y-intercept.
The y-intercept is going to be different, but is anything else going to be different? The points will be different, but it's going to be this equation move down. Instead of it crossing here at 0, 0, it's going to go down here somewhere. That's going to be 0, negative 750. Okay? And then this point over here is going to be that same thing. And then this point, guess what's going to happen?
8,500.
Because 1,600 minus 750 is?
8,500.
Uh-huh. I should get rid of that comma so it makes more sense. Okay, so that just moves it down. So what did C do? Moved it down. That is it. So it's the same equation, but only power C has is to move where it is. A has the power to make it bigger or thinner, down or up. What? A. Yes. A. This first number has the power to make it go up or down and how wide or narrow it is. And the middle number is the one that has the power to move it around. Okay? But why? Why does negative b over 2a work? So let's still look at this here right here. So like how do predicted income and profit change as the concert organizers consider ticket prices? What happens? So if X represents ticket price and Y represents either tickets sold or profit, depending on which one we're looking at, income or profit. So it's either income or profit. How does as the ticket price goes up, what happens to the equations? Yes. It moves, and what does it do? Literally, does it go down and up? Does it go up and down? Yeah, so as the price goes up, it first increases. And once it hits a certain peak, the amount of money you make starts going down, as well as the income. So as that price, like I told you, there's a sweet price for tickets. Hold on, there's a sweet price where you're gonna make more money. And when you go a little bit too much, you're not gonna make as much money. And when you go a little bit too less, you won't make as much money. So it's really important to figure that out. When Mark Hoff was making his game, the Appalachian Trail game, they were figuring this out. They were figuring out how much money should we spend on marketing to make sure we're making the max amount of money here. So how could they make more money instead of making only $8,500 as a max profit? They could try and decrease this number. If they decrease this number, it's going to move it up that way because it's going to make it that they're making more money. So let me give you just a little insight into what Maya asked me yesterday. I think that's we're not going to worry about that. What ticket price is the price that's going to make it the most valuable? What was the ticket price? So where's the ticket price? It's X, right? What's the ticket price that makes it the most valuable? Yeah.
No.
Okay.
Mm.
So X equals ticket price. Y is income or profit, depending on which one we're looking at. What's the best ticket price? $8. $8 is the best ticket price. Remember, this was like a dance or something. I don't know what it was. It was a little concert, fundraising concert. Probably not Beyonce. Definitely not Elton John. Okay, so $8 is the key price. What's the max amount of money they can actually make profit on? It's this. This is the income. They have to get rid of all those expenses. So they only can make $8,500. Come on.
When you're like plugging in 8,
Yes.
do you do 8 squared
Yes.
times? Okay.
Yes. You always do the number with the square first. So if you did 250 times 8 and then squared it, you probably got an extraordinary number. So let me give one little tidbit. Can I erase this or want me to?
No, 250.
Hold on for a minute. I'm going to give you guys a little window into why this works, why this equation, this is Maya saying, why? That's not Maya, that's somebody. Why? Yes, Tajana?
I'm still kind of confused about the graph.
Okay. Can you go further than what you're confused about? So the first thing I plotted was this point, because that's the value of y when x is 0. It's the one that goes on this line. Same thing for this one. On this equation, there is no 0. There is no c. Since there's nothing here, it's 0, 0. So this first point I plotted was 0, 0. This first point I plotted was 0, negative 750. Then the second thing I did over here was found the axis of symmetry by using negative b over 2a. Okay, I plugged that in, got 8. This is when x equals 8, that's the line of symmetry. On this whole line, x equals 8. That means that the graph is reflected over it. So if I have this point here and it's 8 away from the axis of symmetry, I have another point on the other side, 8 away. I can go over here and plot one more point exact distance away. So if I folded the paper, they would match up. Same thing here. This is 8 away from here. I'm going to have another one 8 away from here. Then I had to plug it in to solve what the maximum point was, or minimum. I know it's maximum because it's negative. So I plugged in this x value to solve for a y value. Once I did that, I have a point, xy point. The xy point is 8, 16,000. 16,000. Gosh, really messed me up the whole class. 8, 16,000. Then on this one, I plugged in, if I plugged in 8 again, it would be this minus 750, which means it just moved, that 750 just moved the graph down, but it didn't adjust the graph. It's the same shape, just pulled it down. Kind of makes sense? Almost there? Let me see if I can show you guys this B part, this 2BA thing. Can I erase this here? I'm going for it. I have it on recording. You guys can look at it. I took pictures. I can send that too. Okay, so here we go. Y, understanding the axis of symmetry. This is the axis of symmetry. This is the formula. We want to understand it, right? We want to know why it happens.
Wait, sister.
Yes.
I just finished the first one that we did. Was I supposed to get 16,000?
Yes.
Okay.
Okay, so the vertex occurs, so the axis of symmetry slash vertex. These are the two things we want to understand. The vertex formula is this, which is really kind of weird to me. It's negative b over 2a. It's just a weird way to write it, so don't really mind too much of it, but this is the way we write it. So subtract c. So if we had an original equation, we have this equation, y equals ax squared plus bx plus c. Just like we had just now. We had y equals negative 250 x squared plus 4,000x minus 7,500, right? That was our long equation. And then if we went ahead and took away c, say we take away c, we get y equals ax squared plus bx, which was just like this equation, right? Negative 250 x squared plus 4,000 x. These two equations were the two we were just working with. Okay, so we take away the c because the c just moves it up and down and doesn't alter our parabola at all, right? What we noticed on that graph before that I just had is both of those equations had the same axis of symmetry. True? So then what we would do, and I showed you by graphing those two, so let me just pretend like the graph is still here. We had one here at negative 750, 7,500. One here at 0, 0, one like this. This one went like this. We had the line of symmetry, which was 8, right? So then this was 16, 0. This was 0, 0. This was 0, 7,500. This is 16, 7,500. And our points were, this totally is out of proportion, but let's pretend it's not. It's 8, 16,000, right? And then here it was 8,500. Okay, that was our whole graph. So they look exactly the same. They got moved up and down. I take C off. All it does is change it. Is the axis of symmetry still true? Yeah. Because the axis of symmetry is what we use to find the maximum that impacts that. So the next piece is, if we were to factor this, say I were to factor this out. What I mean by factor is say, what do these two things have in common? What do they have in common? X. X. So we get A plus B. AX plus B. I'm going to do that on this one. You would get y equals, on this one, it would actually be more than that. You'd get let's say negative 250.
Wait, why do you get rid of C? Because it only moves it up and down.
It only moves it up and down. The axis of symmetry still stays true. So you're going to end up here with x plus 16, or 16, yeah, x plus 16, okay? So if we were to do that, what we want to know then is these are, when we factor this, we're going to see that our x-intercepts of this parabola occur at, so what these are is they're giving you your x-intercepts. They're saying when x equals 0, y has a value, right? When x equals 0, y has a value. So let's look here and say, if I were to have my graph here, let me do two graphs on them separate. So on this graph, if x equals 0, I can either have x equals 0, or on this one, my other point would be what? If I were to set this to 0. So this, I'm trying to explain this right. So if I had this, let's say I had 0 equals 12 times x. What's x going to be?
Wait, you know what?
0, right? If I have 0 equals 12 times x, what's x going to be? 0. So if I had 0 equals x times y, what's x going to be? We're not sure, but what could x potentially be? What could y potentially be? So on this, if this is going to equal, we want to know when y equals 0. That means this either needs to equal 0 or this needs to equal 0, right? And if this equals 0, it's just x equals 0. That's one value of x. The other one is having ax plus b equals 0. If I solve this equation, the reason why I'm doing it with numbers is to make it make sense too. If I solve that, I would end up getting, I'd move the b over, right? I'd get ax equals negative b. I divide by a, and I get x equals negative b over a. So what that's saying is, here's my parabola. I'll draw it the same direction. Here's my parabola. Should draw it better. Let me go with okay, here's my parabola. It's saying that 1x, when x is 0, y is 0. So this is saying x is 0, y is 0. And what the other x is going to be when we have negative b over a. Okay? So those are the 2 points I'm going to get. Let's look at this with numbers.
What about C?
There's no c. We've gotten rid of the c because does the c impacts does the c change your line of symmetry?
No.
Never. Because the c doesn't impact it, we're going to get rid of it to analyze the line of symmetry. Yes.
Okay, so you get rid of the C.
Yep.
And then,
So I got rid of the c, and then I said this, in order to figure out, I want to find my x-intercepts when we cross the x-intercept line. So it could be when y equals 0. So if y equals 0, I need to make this equal 0, and then I need to make this 0, because 0 times any number is 0, and 0 times any number is 0. So what would make this be, if x was 0, this would be 0 times b. What's 0 times b? 0. So let's say, let's plug it in. If I had 0 times a, 0 plus b, I'd get 0 times b, which would be 0.
so you're trying to get y to be 0.
Yeah, and I have to do it twice. The other option is then to do this and say, okay, if I had y equals 0 here, I'd have to solve for what b would be. So let's say I did get negative b over a. I'd go a times negative b over a plus b equals 0. This goes away, you get negative b plus b equals 0. You get 0 equals 0. So these are the two values. 0, x can be 0, and x can be negative ba. Now someone tell me, where's the line of symmetry? Where's the axis of symmetry in between these? What's going to be true about where the axis of symmetry is? It's right in the middle, right? It's got to be halfway. So guess what? Because of that, it's going to be negative b over a divided by 2. Oh, it's this value divided by 2, right? Which ends up being negative b over 2a, which is why that equation works for the line of symmetry. Yes.
Do we have to know all this?
No, I'm just giving this as background information, okay? So if I were to, do you want the answers just to look over?
Sure, I also have all the homework.
For tomorrow?
All of that, yeah.
You can just give it to me. You almost want me to take it and look it over? I can just give it to you if you want. Whichever one works better for you. I have planning today. All right, look at it. Then I can see if there's anything underneath that you. Okay. Say hi, Aiden.
Hey, Aiden.
Okay, so is it still recording or did it stop on me? It is. Okay, so let's just test this real quick. I know we're past time, so I should stop. But watch this real quick. I'm going to do, you don't need to write this down. So let's see if this is true. What would make this 0? If x was what? 0. So we have 0, 0 as 1. And what would make this 0? Oh, maybe I wrote the wrong thing. I should have written negative down here, sorry. What would make this 0?
It was 16.
16. So then I'm going to get. So guess what? I got those 2 points. So what's halfway between 0 and 16? 8.
Wait, 0.5 is bigger than 0, right?
0.5 is bigger than 0. Okay, kind of makes, so that's my explanation for you, and I can go over it more. But that shows you how negative b over 2a works. Because here, again, if we were to put negative b over 2a, it's this 16. So b is 4,000. So 4,000 divided by 2 times this ends up being the answer. So that's how that works. Okay. Kind of confusing. I was just trying to show you that so you can see that piece of how it works.
So I don't need to remember that.
Don't need to remember that, but you do need to remember negative b over 2a is how you find the line of symmetry. Math homework is page 472, check your understanding. It is a problem like the profit problem we were looking at. It's going to be a little tricky. If you want to get started before study hall, I'll be available for study hall, okay? I can work with you guys in study hall. Okay? Bye, Aiden. Feel better. I'm going to send you everything home.